So we learned how to write equations for precipitation reactions. There are actually different types of chemical equations. A molecular equation is what we probably think of as a regular chemical equation. It's going to show the neutral formulas for all the compounds as if they were molecules. So in this example of potassium hydroxide and magnesium nitrate, these are ionic compounds and they're dissolved in water, and so they are not actually little units of KOH and MgNO3 They're actually separated into cations and anions, but we show their neutral formulas in the molecular equation. In a complete ionic equation, we're going to show all the species as they actually are. So we're going to show potassium ions and hydroxide ions separately because that's what they do. We'll show magnesium ions and nitrate ions. In a net ionic equation, we're only going to show the species that are actually involved in the chemical reaction. Some of them are spectators. They are just hanging around and they don't actually react, and so we don't show those in the net ionic equation. So to write a complete ionic equation, you really need to start with a molecular equation. So here we have an example of lead nitrate and potassium chloride. What we're going to do to write the complete ionic equation is that we're going to write any aqueous ionic compounds as ions. So this is an aqueous ionic compound. This is an aqueous ionic compound. So PbNO3, there are two kinds of ions there, a Pb2 plus ion and nitrate ions. And so we write those formulas separately. We write those just the same as if we were trying to write the formula for the compound. And we're going to put AQ as their state symbol. There were two nitrate ions in one unit of this, and so I put a 2 in front of nitrate so that this is going to still be balanced. Here we have 2 potassium chloride units. That would be 2 potassium ions and 2 chloride ions, and they're separated. If you have solids, liquids, or gases anywhere in the formula, so S, L, or G is the state symbol, you just copy those down. You don't do anything to them. So those would be insoluble substances. Weak electrolytes and non-electrolytes would also be written as molecules, and that would include the weak acids. So here in the products we have a solid. So this is an insoluble compound, and so the predominant form when it's in this beaker of liquid is that it's a solid. Those ions are not separated, and so we write that as the neutral molecule or neutral formula. This is aqueous, and so we're going to separate those into ions. Any questions? We're showing all the ions. That's why it's a complete ionic equation. Some of those ions are spectators. It's like at a boxing match. The spectators go and they sit in the stands and they watch, and when they leave, they look the same as they did before. The guys down in the ring come out and they've got a black eye and a bloody nose and they're all beat up, right? Something happened to them, but nothing happened to the spectators. So here in this reaction, we have some spectators. The nitrate ions started out as nitrate ions, and they're still just nitrate ions in solution. Nothing happened to them. Potassium was unchanged in the reaction. So in my dating analogy, people going to a party, nitrate went to the party with lead, potassium went with chloride. Well, potassium and chloride hit it off. They are in a relationship now. But potassium and nitrate did not find their soulmates. They're still just kind of hanging out. So nothing happened to them. So we don't include spectator ions in the net ionic equation. Because if this was another ion, like, I don't know, well, let's do potassium. If this was lithium or sodium, the reaction would happen exactly the same way. So the net ionic equation only shows the stuff that's actually reacting. So we would cross those off and write down what's left. And so the net ionic equation, the bottom line, is that lead 2 ions reacted with chloride ions, to form lead 2 chloride solid. Any questions? Let's do an example. We're supposed to write the complete ionic and net ionic equations for this reaction. We're given the molecular equation. So here we've got HI, barium hydroxide, we've got water, and barium iodide. The only ones that can be broken into ions are going to have AQ. If it doesn't have AQ, just leave it alone. So we're going to leave water alone. AQ, the only ones that you don't break into ions are weak acids. Now the book hasn't covered what a weak acid is yet, so let's just fast forward here. These are the strong acids. There's 6 strong acids. Anything that's not a strong acid is a weak acid. So we've got HI. It's a very friendly acid. High hydroiodic acid. That's a strong acid. A strong acid is a strong electrolyte. It ionizes completely. So that will be separated into ions. So let's go back to our example. So because this is a strong acid, I'm going to separate it into the ions. So I have 2 HI molecules. So when those separate into ions, I'm going to get 2 hydrogen ions and 2 iodide ions. And then I've got barium hydroxide. This is soluble, it's an ionic compound. I'm going to separate that into the ions. There's 2 ions, barium and hydroxide. So we have barium ion. I know the charge from the periodic table. Yeah, 2+. And then here, there are 2 hydroxide ions.
So does the 2 then become a prefix to the OH?
The 2 becomes a coefficient, yeah.
Okay.
So because there were 2 hydroxides, I'm going to write 2 OH minus. You could think of this as being like a bicycle. So there's one bicycle frame and there's 2 wheels. When we take the bicycle apart, we have 1 frame and 2 wheels. So that's what I'm saying here, 1 frame and 2 wheels. So those are my reactants. I'm going to go to the products. I see the L. It's a liquid. I'm not going to do anything to it. I just copy it down the same. And then the last one's aqueous, and so I'm going to break that into ions. Again, there's 2 kinds of ions, barium ions and iodide ions. This 2 means that there are 2 iodide ions. It's not an iodine molecule. So barium, 2+, aqueous, and 2 iodides. Any questions? That's the complete ionic equation.
So is this the case where H2O acts as like a acid or base type thing, or
Is water acting as an acid or a base? It's actually the conjugate base
conjugate base?
in this example, but we don't know about that yet. So that's the complete ionic equation. To make the net ionic equation, we're just going to look and see what's the same on both sides of the arrow. Help me out there. I minus? Yeah, the bariums. So I got barium here, and I got barium there. So we'll cross those guys off. And I've got iodide on both sides. 2 iodides there and 2 iodides there. So the net ionic equation, I'm going to copy down what I did not cross off. So I'm going to get 2H+, aqueous, and 2 hydroxides, aqueous, making 2 water molecules, and water's a liquid. Now what's funky about that equation? 2, 2, 2. A proper equation will have the lowest whole number coefficients, right? So this is balanced and it's nice and everything, but it'd be better to cross those 2's off. Sometimes that makes a difference, other times it doesn't make a difference, but that's how it's supposed to be. So net ionic equations.